Welcome to the session, leveraging a distributed architecture to your advantage. For those who don't know me, my name is Michelangelo van Dam. I'm a professional PHP architect. I also run a community in Benelux. I'm a coach at Coder Dojo teaching kids how to code. And I contribute to open source projects. Last but not least, I'm a Zen certified engineer. Not that that really matters, but people like it to see it on the slide. So let's start off where I started my PHP development, and I think most of you will recognize this. It's called a single LAMP stack, and LAMP being the acronym for Linux, Apache, MySQL, and PHP. People in the room that started off that way? Yeah, okay, yeah, so I don't think it's going to be familiar. So the Linux, Apache, MySQL, PHP stack was the thing that got us to where we are right now. It allowed us to build applications, and it allowed us to to have something that we call a career in web development. The nice thing about this, it was layered. So you started off with your Linux distribution, whatever flavor you had back in the day. I mean, mine was running on Slackware. People still remember Slackware? Oh, okay. I'm not the only one there. Good. And then Apache Web Server, because that was the only good one you had back then. Well, you had the what was it? The Netscape web server. I'm not sure. People use this? No. Okay. Never mind. And MySQL as a database, that was very popular. And PHP, that was the thing that got us our jobs. So we built these small web applications, things like WordPress and Joomla, Drupal, Typo3, and a lot more frameworks came out, all building on these web technologies. Even now today, our own website is running off WordPress because it's easy. You deploy it in like 15 minutes, you put some content on it, and bam, you have a website. So simplicity is ultimately a matter of focus. And we as developers, we don't want things to be complicated. We want things to be, as we call it, easy. Because for us, it's a single point of concern. It's easy to maintain, easy to distribute, and easy to protect. And I think back in the day, everyone was dancing this way. I mean, he didn't, right? Unfortunately, easy didn't scale well. Easy didn't give us the ability to handle more loads than just a few hundred visitors on our website. And also, the data that all these people are generating was a lot more than what we could store in our single MySQL database. And then we had these bosses and clients saying, yeah, we want to have more features. And those features were not provided out of the box of the tools that we implemented. And then, oh yeah, we need to be HIPAA compliant, PCI compliant, and guess what? There's something coming called GDPR in Europe. We also have to be compliant with that. So we're basically looking at our software and think, hey, this is like a shed, and we cannot extend from that. We can not add an additional porch or a veranda on top of it. So we like more. And then we end up with this. All right, just among friends, who has been there? Thank you very much. I don't feel alone right now. So yes, we were adding more and more to our application, and then we ended up with memory could not handle it. So we needed to scale. So let's look back at what we had. We had this very nice LAMP stack. So what is it that we do? There you go. We scale, right? This is what we had. Well, no, this is not how it works. So, the scaling mistake number one, don't add more machines than think you're scaled. Right? Scale with a purpose. And scaling with a purpose means that you need to decide what's the responsibility of this little thing. So you need to separate the responsibilities. You also need to figure out, okay, what are your weakest links? Because those things will be hammered by all these requests. So you need more of these weakest links. And then look for alternate, better solutions. Maybe change the web server. Go from Apache to Nginx. And also, don't overscale. It's not because you have from, let's say, 800 users to 8,000 users that all of a sudden you need to have 8,000 machines. No, it doesn't work that way. So don't overscale it. So if you want to scale your application, you will probably get into something like this, where you have Nginx and PHP FPM running on Linux devices, and maybe you have that also separated out. You have your MySQL database somewhere in the middle running independently from your application. And life is all good. But then the next question you have to ask, is your app ready to be scaled? Because when we started off with the LAMP stack, I mean, when you put your WordPress on top of that, that's fine. But now you have that whole distributed architecture underneath, and when you try to run your WordPress, all of a sudden it doesn't scale that well because the app is not ready for that. So figuring out your hard requirements is one of those key things. Where is your application limiting you from actually scaling up? So when you do the analysis of your code, you come to these little things like, hey, we have a database connection here, and we want to use this. And this is already surpassed the current scope, but yeah, you can have all kinds of environment variables, or if you use an identity management system, you can now have them provide you the access to the systems that you need. So you can take things out of your app, move it into some other form, more centralized information collection, and then you can add more items. You can actually build on top of things that are started off as very simple things and now become very complex. Things like caching. Maybe you want to have a search engine. Maybe you want to have a load balancer. Maybe you want to have some replication. Queues. Workers. APIs. And the list goes on and on and on and on. So your very simple application becomes very complex very quickly. Just to give you an idea, bam. Remember that LAMP stack? It's not as LAMP anymore nowadays. So all of a sudden you have what they call a proxy in front, a distributed architecture behind the proxy. You also have shared file system or virtual file systems in between. You have some Elasticsearch, you have some caches, you have, by the way, everyone changed from MySQL to MariaDB, and then MongoDB somewhere in the between. You have some queues up there, you have some workers listening to those queues, and all of a sudden, your very simple application that you started off with becomes very, very complex. People know Marco Pavetta in the room? Ochranamas? on Twitter? No? Well, he's the guy, whenever he goes to a conference, he talks about event sourcing. I can highly recommend it, but that's his feelings towards event sourcing, because it is so complex and it becomes so, so critical in most applications right now. But you really want to have to see that talk, because that is where you're going to. Because now all your application components are going to trigger events, and now your events need to be processed in a structured way. It all comes down to making choices. And making choices, when we first started off, we had, where do we run our application? Well, of course, we started off on-prem. And then people said, oh, you need to have cloud, or maybe even hosted. And you know, the majority was saying, you know, hosted is not the solution anymore, and on-prem, you don't need to do this. Move to the cloud. Trust me, I'm a professional. But moving to the cloud also comes down to a whole bunch of other things. Because all of a sudden, you're no longer in control of what's happening. And when you move to the cloud, and your neighbor moves to the cloud, and the table behind you moves to the cloud, and the table next to you moves to the cloud, and this happens, yeah, there's a lot of people that don't have their website up and running. So, going through this whole journey of our very simple application becoming more complex and need to scale up, and then we come to a solution like, oh, we move to the cloud, all of a sudden we have to deal with a whole bunch of other challenges, let me put it that way. And for us, it's always like a technical challenge. It's from the get-go on nothing but challenges, challenges, challenges. But for your user, they end up with this. They type in the domain, and yeah, it's not responding. At that point, you're losing customers. That's where you lose your clients. That's where everything goes really wrong. And I don't think I need to say it, but this is bad. So I come to the conclusion that my scaling mistake number 2 is, don't put all your eggs in one basket. Okay, but how do we actually prevent all these kind of things from happening? We need to have a strategy, and the strategy is key to all the things that we do now on the internet. So when there was this major outage on AWS, all our customers were still online. And we tweeted this out like, okay, why is this? And we have our clients served. And a lot of people were like, how do you do that? So here's the magic behind it. So what did we do to stay online all the time? Well, the first question that we ask to our clients is, can you live with reduced capacity? Still be online, but having slower web pages. If the answer is no, yeah, the challenge will be a lot more difficult. But if people have the decision between being online, being a little bit slow, or not being online, people say yes. So that was the first question that we asked. And then we looked at what is out there. So you have Amazon, Microsoft Azure, Google Cloud, DigitalOcean, OpenShift, IBM Bluemix, Heroku. But don't forget, you also have the hosted versions and on-premise. And people were like massively going to the cloud and forgot all about these hosted services. But these hosted services can be your lifesaver. But you can also choose to say, you know what, instead of having only one cloud provider, we take 2 cloud providers. So in Amazon Web Services, what is a typical setup? Well, you have your elastic load balancing right there. And then you have everything distributed. One in West Europe, one in North Europe, maybe one in South America. Just for, let's say that Europe gets wiped away from the planet of the Earth, at least your website will still remain operational in South America. Not that you can serve your customers anymore, but that's a different story. Your site will still be running. And the same thing goes with Microsoft Azure. You can have everything distributed in different regions of the world. Some close to, I'm from Europe, so yeah, West Europe and North Europe, those are closest to me. But also pick one on another continent. Just to make sure that whenever something happens, everything is still distributed. But why stop here? As I said, don't put all your eggs in a single basket. Maybe you want to do it this way. Okay, it's not going to be cheap, but if your goal is to have an all-time running web application, well, this is one of these solutions. I also have to put this warning up because it's not just that you have your application up and running, but all the things that your application is processing, all the data, needs to be distributed. So you will double your expenses for all the transactions that you make between all the cloud providers. But that's not going to be a significant cost if your goal is to be uptime all the time. The third scaling mistake is being not ready for a disaster. And the disasters can be everything. And as we already showed you, cloud providers are not safe from disasters as well. Welcome to the Netflix Chaos Monkey, or the Simian Army. So the most known one is the Chaos Monkey. Who hasn't heard of this before? Okay, so Netflix you do know, right? Okay. They have these tools for their streaming services to make sure that everything stays operational even when stuff goes wrong. And they open source this. And now they have like this massive tool suite, a suite of tools that help you to have a resilience built into your applications. So the Chaos Monkey, for instance, it decides, you know, that the cluster of databases that you have in Northern Europe, gone. It's not accessible anymore. And it does this in production during office hours. You're laughing. You know why? Because in production you will get like the normal feed that you will get in any given day and during office hours. So if something goes wrong, you still are in the office to actually do something about it. Because disasters are never happening during office hours. Most of the time it happens on a Friday night or in a Saturday or a Sunday right before a national holiday, and stuff goes really wrong and you have to haul your butt to the office trying to fix it, because at that point the VPN is not working, so you cannot do this remotely. Disasters never have a schedule that fits your schedule. I've seen people running out of dinners, Christmas dinners, because something broke. So running these tools from Netflix, and Netflix, I am so grateful for them for providing us these tools. They allow you to do this on your production system, where if something goes wrong, it will be there. During office hours, while you're still working in the company, and it will do on a very random basis, it will start taking out services that you have. So you can see whether or not your infrastructure, your architecture, is resistant to these kind of failures. And if not, it gives you at least insights on how to protect those weakest links. And the Chaos Gorilla is even worse. So you have the Chaos Monkey just being nasty, plugging things out. The Chaos Gorilla just wipes everything. So yeah, if you want to take it a little level higher. You also have Chaos Kong. Well, I don't have to imagine what that will do. You have a Janitor Monkey, Doctor Monkey, Compliance Monkey, Latency Monkey, Security Monkey. So the whole army that you can get from Netflix for free will allow you to actually build in resilience. Find the weakest links in your application architecture and make sure that your application can go into disaster mode while you're still having Christmas dinner with the family, and you don't have to worry about it. Well, there's, especially here in the US, I've noticed there's this mentality to prepare for the worst. I still have to train a lot of people in Europe to get that into that mindset. But it's true. When you're prepared for the worst, when the worst happens, it's okay, because you know you will be ready for it. Scaling mistake number 4, don't automate your deployment process. I had wonderful conversations here between when I did my workshop on Monday up until now with a whole bunch of people that said, yeah, we're still doing all the deployments manually. Just a show of hands, who's still doing manual deployments? There you go. It's not a lot, but still a significant number of people. Everything after the commit can be automated. So the moment that you commit into your branch or into a master branch or a deployment branch, it doesn't really matter. You choose your own strategy. But the moment that you commit, it should be hands-off. Let the machines take over. Don't be afraid, they're good at it. Computers are very good at doing repetitive tasks very well. Better than humans. So, a common situation, you have your developers, they commit, it goes into a SCM. Over here it's a version, most of the people are using Git or Mercurial. It doesn't really matter what kind of system, as long as you have a versioning system. Because the moment that there is a change in there, you have your centralized CI, and again, Jenkins is one of the tools, but it does not mean that you need to use Jenkins. We use it. It sees that change, starts doing all the things that are necessary, gives you feedback, and executes the delivery. And depending on your strategy, you can have it done into a test environment, so you can have a QA team look at it. You can push it into staging, so you can actually have automated acceptance tests running on it. Or you can push it into production. But the human interaction stops right there. That's it. You commit, done. And building the pipelines, it's all depending on your own situation. You start off with your unit tests, you have some metrics calculated. You can provision your targets, provision some workers. In the meantime, you also have your databases provisioned. of course, some integration test, and then you promote the branch. And the promotion of the branch can be, okay, now it's ready for deployment, or we move it to the next phase, where you go through PCI compliances or HIPAA compliance regulation stuff. So you can do like automated checks in there. So depending on your own situation, you can go very far in these pipelines. But once you have these pipelines, you can say, oh, you know what? I want to check my Composer log file with Sensio Labs CVE checker. Plug it right through. It's just one of these elements that you can just plug in. And all of a sudden, you're improving over time the whole deployment process. Makes your life a lot easier. So what can you choose from? Well, you have Jenkins, of course, Bamboo from Atlassian. If you guys are using PHP Storm, JetBrains also has TeamCity. Those are the things that you can run locally on your own machine or in a server on-prem. If you don't want to bother with system support, well, run it in CodeShip or Semaphore, Travis CI, PHP CI, Circle CI, Continuous PHP. I mean, just look at CI online service in Google and you will get like a very big list of services out there. If you want to do some additional steps like static analysis, Code Climate and Sensio Labs Insight are very good tools for that. So all of a sudden you can just plug it into the whole chain of things. And this will not only make sure that your code quality gets better, but also detects and spots, issues. And the tools that we use, well, we have Bash, we have Ansible, we have Puppet, Chef. We're using Fing. Who's also using Fing for the build stuff? Yeah? Okay. We use it because the guy who created it lives in about 2 hours away from where I live. So whenever I have a problem, I drive up to him, knock on his door. He doesn't like that, but it's okay. It's the PHP version of Ant, if you're questioning it. For deployments, we use Capistrano. And for our environments, we're using Vagrant and VirtualBox or VMware or Xen, depending on what the customer is actually using. And last but not least, Docker. It makes our lives so much more easy. We just create containers and put it up there. I see Chris smiling over there, so thank you, Lee. You probably like this, right? Sure. But yeah, seriously, automate your deployment process. For me, it also gives me the ability to deploy multiple times a day. And deploying multiple times a day gives me a lot of freedom. So I can enjoy life more to the fullest and don't have to worry about all the after effects of my commit. And yeah, we do have everything in builds. So this is our build pipeline. As you can see, a lot of stuff happens there. And when something breaks, we get notification immediately. And if you were in my workshop, I had this mentioning about, okay, you have non-blocking errors and blocking errors. In this case, it was a non-blocking error because it was the failure was at what is it? The initial state of the checkout. So it couldn't check out from the SCM. So it ran through the whole code. Maybe we can stop right there and say, oh, yeah, if you cannot check it out, you don't need to go through the whole process. It doesn't make sense. But everything else was just, okay, the moment that we commit, it starts running again. Then we commit again, it starts running again. And you can see it even keeps track of how long it took for you to process your commits. And sometimes it takes a little bit longer, especially over here, where you have 2 minutes. And then we said, well, this is taking way too long. So the composer setup, we optimized it and reduced it by half. So the whole process goes a little bit quicker. As you can see, having these build pipelines also gives us the ability to further improve, make things faster, make things more resilient, make things more better. And we just plug in more and more of these steps into the pipeline just to get a better result in the end. Because if we can trust what we deploy, yeah, we don't have any reason to worry. So, let's recap here. When you're preparing your code to scale, you need to be aware of all the things that might be infected. So if you're using databases, try not to lock in the database connection inside your application, but outside. Like I said, poor man's job is to use environment variables. Not really a good idea, so whenever there is a crash of your system, your environment variables are being exposed in the dump logs. But that's a beginning. Look at other tools like identity management systems that you can implement. HashiCorp, if you are familiar with Vagrant, the company behind Vagrant, HashiCorp, now has Vault. So have a look at Vault, which is an identity management system service. And it allows you to just use their API, have the credentials fetched for your web server to connect to your database, and it will just generate you a key that you can set, okay, this is only valid for like the next hour and a half, or maybe for 24 hours or something. So you can have key rolling right there. You don't have to worry about the management of your keys. It will take care of that and makes your application a lot more secure. When online is important, when high availability is important, try to think about scaling over multiple hosting providers. Maybe you want to scale between Amazon and Azure, or maybe you want to scale between Amazon and a hosted solution. Also, having the whole build pipeline in place allows you to immediately distribute to all the systems that you have in production, and not just the one and then replicate from there. Test your resilience for failure. I mean, the Netflix Chaos Monkey tools, the whole Simian army, they're just awesome tools. If you're using any form of virtualization, either hosted or in the cloud, just give it a try. The worst thing that can happen is that you find weak spots, and you can solve those. Automate all your processes. Put it in a build pipeline. If you don't want to mess with a CI system like Jenkins or a online service like Travis, a shell script where you say, okay, first do this, then do this, then do this. If that is your build pipeline, use that. You can add more commands into the whole flow. And release with confidence. I mean, I'm in an airplane having not so 100% good internet connection, but I can release all the way from 30,000 feet up, knowing that my internet connection can be blown away any second, but I still do it. Or I'm at a pool, I get a notification that we need to do an emergency update because there is a security issue. I can write that fix, press command, press commit, close my laptop, and enjoy the rest of my stay at the pool. I don't have to worry about things. That gives me, as a person, a lot more confidence. And I want everyone in this room to have that same confidence. So that is it. I do want to add here a shameless plug for our PHP Benelux conference. Ticket sales will start tomorrow. It's a small conference in the Benelux. It's a community-oriented conference. If you like Belgian beer and you like chocolate and you like to have good sessions and some epic events, come and join us. A couple of people have been there. Ask them how it was, and they will tell you it was epic. So yeah, come and join us. Last but not least, I also want to ask you to please leave some feedback so I can improve my talk. And while you're going to the Join In page, grab the slides so you can have a look at it for yourself. And that's it. Are there questions? No questions? Okay, well, thank you very much. And I would say enjoy the conference, and I will see you around. All right, thank you.